Thank you. We're working with methane, and here's your molecular formula. But when you write out the Lewis dot structure, these are dots. You can think of electron pairs bonded. There are 4 carbon-hydrogen bonds. Now the question is, how much energy was liberated in the formation of this compound? Okay, so we have a problem. All you do is you'll be given or determined, and that's to be shown how to do that. You'll be given a structural formula like this. Well, what do you see? You see 1, 2, 3, 4 carbon-hydrogen bonds in that structure. Well, look on your table now and find carbon and hydrogen if you can square them up. It's 411 kilojoules. If we're forming, it's exothermic 411 per CH bond. So if we have the delta H bond energy for CH4 is equal to 4 times the energy associated with a carbon-hydrogen bond, which is 4 times 411 kilojoules. And so 4, here, 4416 kilojoules exothermic. Okay, forming the compound. If you want to break the compound, how much energy you got to put? Same number. See the idea? Very straightforward. Okay, so there's one example, and so you can apply this table billions of compounds if you've got the structural formula. All I got to do is look up the energy numbers for what's going on. This is methanol, methyl alcohol, another word for it. Okay, and so what you need to do to answer this question, of course, you'd have the table with you, and so you count up the types and numbers of bonds. Well, 1, 2, 3. We've got 3 carbon-hydrogen bonds. We've got 1 carbon-oxygen bond, and we've got 1 oxygen-hydrogen bond. Okay, it's 3, 4, 5 bonds. Okay, when you list them, be sure you've got 1, 2, 3, 4, 5. See how I'm counting the bars in here? This has got to match however many. If you're short, if the bars in here don't match, go back and check. You missed or got too many, you put too many bonds in. Well, now it's simple enough. You just look up the carbon. Well, we already know what carbon-hydrogen is, 411 kilojoules. So what is carbon-oxygen? So I look on here and I find where a number lines up. Here's oxygen and carbon 358 right there. So I will come in here with 1 times 358 kilojoules, and then I need to look up oxygen, hydrogen, so I find an oxygen and hydrogen that line up, 459 right there. And so I put that one in, 9 kilojoules. And so this is 1644 kilojoules. This is 358 kilojoules for the formation of the carbon-oxygen bond, and 459 kilojoules for the oxygen-hydrogen bond. And the sum of the individual bonding energy, all better. Here. We got the sum of these is 2050 kilojoules, total bonding energy of methanol. Okay, pretty straightforward. All you have to do is count up the bonds in there. We'll do one more, and then we'll move on to atomic theory. Okay, this is formaldehyde. It has a double bond. You know, some molecules will have double bonds, some triple bonds, but most have single bonds. Okay, you don't have 4 bonds. The highest you can go is triple bond, but that's not. This is a double bond. Well, we have some double bonds down here. Carbon oxygen double bond is 745 if it's not in CO2. Well, that's formaldehyde, and that's not CO2, carbon dioxide. So 745 when we get there. So when we look at our bonds, we have 1 carbon oxygen double bond, and that's 1 times 745 kilojoules for that one. Then we have 2 carbon hydrogen bonds, and that's still 411. 2 times 411 kilojoules, like that. 745 kilojoules. 228 kilojoules for the carbon hydrogen. 5, 6, 7, 4, 5, 6, 1567 kilojoules, and delta HB for CH2O. Very straightforward idea. So more will be applied to this idea, but at this point I felt well, to take, since it deals with energy, it's a good exercise to see that these numbers apply to molecules as well as reactions in the process of calculations.